Unfortunately, I got a little bit ahead of myself. And before we get into ideas with cardinalities of finite unions, I do need to go through a couple more examples here just to keep building up our confidence with these operations, where the main thing you really need to be careful of here is minding parentheses. Just like with the order of operations, you always treat parentheses as the most important thing to handle first. So if you see stuff in parentheses, do that before you do anything else. And let's get an example of how that works in practice. So for this example, we are given the sets with the universal set 1 to 10. A is 1, 3, 5, 7. B is 3, 7, 8, 10. And what we want to find is the sets A intersect B quantity complement, as well as A complement union B complement. Where for that first case, we want to find A intersect B complement. What we should do, because we have that parenthesis there, that set of parentheses there, is start by finding what's inside of them, A intersect B. The elements shared to both A and B, where this is 3 and 7. As A is 1, 3, 5, 7, B is 3, 7, 8, 10, only 3 and 7 are common between them. So if we want to find A intersect B quantity complemented, let me put that as a parenthesis, not another prime, that would mean finding the complement, that's a terrible curly brace, but I'll accept it for now, of the set 3 and 7 within the context of the numbers 1 to 10. So here, that's the numbers 1 to 10 except for 3 and 7, which would end up being 1, 2, 4, 5, 6, 8, 9, and 10. Again, everything 1 to 10 except for those, because that's what the complement says. Take everything else. Meanwhile, if we want to find A complement union B complement, much like with the order of operations, when we wanted to treat exponents as being more important than anything else, we treat primes as more important than anything other than parentheses. So we'll start by finding A complement as well as B complement, and then we'll take the union of each of those. So you can kind of think of this as being like we take parentheses, then we take primes, then we take unions and intersections if there's stuff left at the end. Anyway, here if we're taking the complement of A, that's everything other than 1, 3, 5, 7, which would be the even numbers, or 2, 4, 6, 8, and 10. While B isn't quite so obvious, that ends up just being the weird little clump there of 1, 2, 4, 6, excuse me, not 6, I was looking at the wrong one for a second, 5, and 9. So if we want to take A complement union B complement, what we will end up getting is 1, 2, 4, 5, 6, 8, 9, and 10. That is, we'll get 2, 4, 6, 8, and 10, 2, 4, 6, 8, 10 from A, along with 1, 5, and 9 from B. Or in other words, we'll get A intersect B quantity complement, which hints at a very important rule, a very important set of rules that we're going to be seeing later on in this chapter called De Morgan's laws, or De Morgan's rules if you prefer using them in other ways. But we're not quite there yet. So before we get there, I'm going to go back to what I said I was going to do at the end of the last video before I got a little bit ahead of myself, and talk about what happens when we do those unions. Because again, actually, we took 5 and 5, but didn't end up getting 10. So something slightly different going on there. Something we need to be a little bit careful of, and that's what we're going to see to finish the section.